Today I have a project that I think some of you South Bend lathe guys will find interesting. I recently picked up a set of metric and American dials that I'm going to put on the lathe today, and it's a little bit of a process, and I'm going to show you guys the journey of it. So let's take a look. So the kit has two dials, two setups here, and I'll show you what the pieces are. So the first part is this cam ring. Now this gets bolted right to the bushing of your compound and your cross slide. It's got 3 screws. We have the metric dial, and it has a set of gears in there. And then we have the standard American dial. This is made from a company called New Era, and the drawing shows 1979. So I found these. This is a new old stock kit, so I have to take my time on here because I don't think you could get these anymore, and they were a little bit pricey. So the two different cams move together. But as you could see, they're cammed. They're not the same diameter here, so they're pretty cool. Really high quality parts here. So what we need to do is we need to drill out. We have to take off the old dials, and then we have to drill out the bushings. We have to mark it. Really exact, and drill it out, put these on, and then what this part does is this slips over your existing screw, and it's got 2 set screws in here, and what you have to do is we're going to have to put the drawing calls for 3/1000 includes a 3/1000 feeler gauge, 3/1000 space in there. So we'll put that in there, and then we have to spot drill the screw once this is slipped on, and then use these little grub screws to lock it in place, and that's actually going to be turning the screw. And then the same thing with this. This will slip on, and we have to spot drill and use these 2 grub screws. So that'll be that. All right, let's take apart the cross feed. We'll start with the compound actually. Let's do the compound. So I unloosened the nut and took that off, and now you have your ball crank, and you have to save the pin in there. It's a little tiny pin, little 1/4-inch pin. So we'll just put that to the side. Here's our original dial. This is a direct reading diameter. Nice dial. And the bushing. So what has to happen now is this thing needs to be drilled out, and this has to be screwed to it. Now this is a little bit tricky here. So what I did was I made up some parts, and this is the part I made. It's a little plug gauge. So this will fit right in here perfectly, and then this slips right over there. And really, in essence, what we need to do is line up this witness mark with the old witness mark and clamp it and center punch, and there you go. So I ran into a problem. These are my transfer punches, and I wanted it to be really, really exact. And these slide around a little bit. So what I did is I made a little tiny bushing here. Turned it on the lathe. It kind of got banged up, but went in, was able to center punch, and we're good to go. Now we're going to set up in the mill, and we're going to drill this out and tap it. I wanted to give you guys a look at the drawing that came with it. So this was drawn May 16th of 1979. I can't read who did it. But so anyway, let's take a look at the screw information here. Now the drawing shows for a 13-inch lathe we need number 1032 screws, 1/2 inch socket head cap screws. So we're going to set up on the mill right now to drill and tap them out, and we'll see if it fits. Because I don't have a wiggler, I'm going to locate these holes using this little punch here. I just reclamped this. I put some brass shim stock in there. I wasn't comfortable with just binding it to the threads gently. I didn't want it to move, so I have some shim stock in there, some brass shim stock. I got a V-block, and we're going to drill our second hole now. Alright, you'll have to forgive me. I need to put my OptiVisors on because I am blind as a bat. 2 weeks after my 40th birthday, it's like somebody flipped a switch and my eyes stopped working. Alright, drilling is done. Got 3 holes in there. It's a number 21 drill. That's this pilot drill for the 1032 tap. I got the tap inside the small little Starrett tap handle, and it doesn't have a pilot hole in here, and I don't have a female tap guide, so I'm going to use the force and just wing it. Alright, that's nice. Move this table a little bit, give myself a little more room. The ultimate in manual operation. Handheld. last and final one. These first couple turns is pushing and correcting and pushing and correcting until it starts to guide itself correctly. All right, that's tracking beautifully. Now the moment of truth. We'll see if the retaining ring fits as it should. Three tapped holes. Hope it's focusing nice, but there they are. I'll set up for a new shot so you could see you could see if it fits along with me. So here goes the moment of truth. Got our holes drilled, got them tapped, counterboard. Now we're going to see if everything fits as it should. Now the way this cam works is this cam ring has a little bit of play, so I'm going to lift up a little bit on it because these gears here, the weight of them pushes down and makes them bind up a little bit. So I'll show you as I'm installing this here. I like that. See that? I like that. Free, nice and easy. That's how you want them to spin. The next step is to spot drill the screw, so the grub screws will hold it for this piece. So what we need to do is push all your backlash out, and what I do is I turn it a little bit to bring the screw out a little bit. It takes all the backlash out, and I need the 3/1000 feeler gauge here for my play. I'm going to put this right here. Perfect indentation for this little grub screw. I don't think I need my shim anymore. Alright, time to drill the next one. Perfect. Flat, countersunk. Dials are nice. I like that. Now that the dials are all installed, they're working pretty nice here. We have one more step to do, and that's to drill this section out here to attach the ball crank to it. And that's, I think they call that a Dutchman pin. It's an 1/8 of an inch pin that gets drilled between the inner diameter of the ball crank and this screw here. Now I tried to do that with a pistol drill, and I won't show you what it looks like because it didn't come out too pretty. Luckily it didn't affect the functionality at all, the screw. I chased the threads with a die to clean them up. But what I'm going to do is I'm going to machine a little collar for here to screw onto it, and it'll be flat, and then I'll turn it vertically and put it in the mill and then drill so the drill bit won't walk around, and hopefully that's going to rectify the problem. So I'm going to set up on the mill. Actually, before I do that, I got to turn the piece, so I'll set up for that and let you see that, and then we'll continue. Now the thread pitch for here is 5/16 24. For 5/16 24, we need to pre-drill it with an eye drill. Now that we got the hole drilled, it's time to tap it. I got my 5/16 24 tap in the handle and ready to go. Just put it in my live center. Now I'm just going to tap, I don't know, about halfway into it because I'm going to part this off. I only need a small little section here. This is a real fine thread, so it's very easy to do. Okay, that's good. Before I unchuck this, let's make sure our threads fit and fit well. Yeah, that fits great. Alright, I'm going to part this off, and then we'll set up in the mill to drill out that pin. For parting with this lathe, I always put it in back gear. I just never have any success with this parting at higher speeds. Not bad. Not bad at all. Alright, I have my piece done. I have the compound screw extender clamped up in a V-block, and I'm going to screw down the little backing plate here that I made. Now I made this so it sits a little tiny bit proud of the end of the screw. So what I'm going to do is I'm going to take a mill and I'm going to mill it completely flat to help prevent any kind of walking from the drill. Actually moved it a little bit too deep, but before I got to the screw I backed down, so we're good now. Alright, I got the position marked and I'm about to spot drill it now. That looks good. Now we're going to pilot this and get it ready for reaming for 1/8 of an inch pin. Alright, and that's that. Alright, we got our pin drilled, and it isn't pretty. I won't lie to you, it isn't pretty. But I figured out how to do it, so the next one is going to be nice. But it works, everything is functional. Now what I need to do is put it all back together now. Homemade cross feed and compound nut wrench. Just basically milled out a little section here on an old spade bit. Works perfect. Alright, everything's back together. The dial spins nice. I do have to tweak it a little bit. There feels like there's a little bit of tough spots throughout here. Might be something with the screw extender rubbing or something, but I'm going to find it and tweak it and take care of it. I'll do the cross feed off camera at another time. I no need to put this into the video because it'll just be too long. But you know, you get the point. You pull these guys out if you want to reset the dial, and that's that. These dials are a great upgrade to the lathe. It'll make converting metric numbers really fast without having to do any kind of extra calculations. This was a fun project, a lot of lessons learned, And until the next time, thanks for watching.